Thank you. My name is David Ongo. I work as a thematic
Can you make
expert
your,
at
yeah, okay,
the
perfect, yeah.
yeah. I work at the IGAD Climate and Prediction IGAD Climate Prediction and Application Center (ICPAC) in Nairobi as a Earth observation thematic expert. So I will quickly run on what we do at ICPAC and try to merge it with some of the things that we do under the GMS and Africa Consortium. So allow me to start with the introduction, what ICPAC is. So ICPAC was a drought monitoring center here in Nairobi back in 1989. And then in 2007, there was a protocol that was signed between the Drought Monitoring Center and the IGAD, now the IGAD to form ICPAC. So from then, we've been moving, trying to bring in new members into the fold to continue to grow the center. And over the time, ICPAC has been designated as a regional climate center for the Eastern Africa. It holds also a membership under the AUC NEPAD as a water center of excellence, and also an observer status within the UNFCCC. Currently, we are serving the whole region, that is the Greater Horn of Africa, with 11 countries. We have both the countries that are within the IGAD countries, and then the other countries that are served within the IPAC, making 11 member countries, serving around more than 300 million people. So over the time, we've been moving from the initial drought monitoring to many of the services that are all coined around climate services. So in relation to that, we have a number of key products and services that we're currently working on, including climate monitoring and forecasting, which I'll explain more. We have a very robust disaster risk management. There is issues to do with agriculture and food security, water resources, environmental monitoring, where GMS and Africa is actually sitting. And then we have climate change, capacity development, climate information and production. So the idea that ICPAC is trying to come up with is to fuse the issues around climate monitoring from very few hours to the whole climate change scenario that is over 60 or 35 plus years, and in order to help in strategic planning and scenario building. So it's a synergy between almost present monitoring to going back and also projecting into the future. So we have different timescales in which we are observing and looking at the forecasting mechanisms from very few hours, weekly, monthly, seasonal, all the way to climate change. And response to that, we are looking at response and relief, preparedness planning, and also strategic planning and scenario building in order to help relieve people that might be affected by a number of scenarios as a result of climate change. So I'll just like to point one particular area under this particular category is this, I don't know whether, yeah, this particular scenario. I think for the East African region, we've not been experiencing anything like cyclones. But recently, I think if you've been watching the news, we had Cyclone Hidaya hitting very close to Tanzania and very close, around 300 kilometers away from the coast of Kenya. We had a Cyclone Ali. So within the region, we're also experiencing some extensive sort of new phenomena that are not used to this particular region. And that makes ICPAC's work very important in relation to monitoring some of these conditions. A few years ago, between 22, actually 2 years ago, we had the desert locust, something that has never happened for a very long period of time. But because of the issues related to climate changes, we are now experiencing some new phenomena. I cannot even emphasize issues to do with flooding and also drought around this region. Currently, we're experiencing a lot of drought, especially in Kenya and Tanzania. And it's already projected that in a year or so, we'll be also experiencing a drought of the similar magnitude. So in relation to all that, APAC is trying to move away from the normal reporting of a hazard, but to include the impact-based forecast. Like in case when an event occurs, how much impact is it likely to cause, and how much damage is it likely to cause to the member states. That is the 11 member states. So we have a number of platforms that we've put in place in order to monitor some of the conditions. We have the East Africa Drought Watch, which has a number of indicators from precipitation, soil moisture, and we are also looking at vegetation just to make sure that we're able to inform people in advance of eventuality in case of an event happens. We have the Hazards Watch. We also have the Agriculture Monitoring for Eastern Africa, and then the Water Watch. So in that, we're also doing a lot in relation to using the Earth observation data, particularly rainfall data. We have a wide network of ground stations where we are able to merge, blend the graded data and the available ground station data in order to just trying to improve the accuracy of the data for forecasting purposes. So in relation to GMS and Africa, GMS and Africa is a project that is being funded by EU and also managed by the Africa Union. APAC is the lead consortia for East Africa. We're having a number of institutions within the region, including the Uganda Wildlife Service. We have the Kenya Forest Service in Kenya. We're having some others in Djibouti, Eritrea, Ethiopia, and among countries that are forming our consortia. So we are using Earth observation data to monitor three aspects. We have the tropical forest monitoring. We call it the East Africa Forest Watch. We have the natural habitat monitoring, and also we have the regional seasonal monitoring. All these are using a number of Earth observation data, both from Copernicus as well as other providers of data. So we have a number of platforms that enable us also to disseminate some of the products that have come up from some of the analysis that we've done, where you can be able to log in and discover most of the data sets that can help you understand the rangelands. We have issues, data sets like the NDVI, the dry matter productivity. We have FPA, FCover. We have leaf area indexed for a number of regions. And then specifically, we are using the same data sets to monitor rangelands and protected areas at different scales. We have in the national scale, like this particular one, I'm able to showcase Kenya. We have
2 minutes, David.
Okay, we have in the hotspot level that is at a level of protected area. This is Tsavo in Kenya. We are able to see the trend in the vegetation presence, the vegetation condition within the protected areas. This is drought condition within the regional level, but also you can also be able to view it from a protected area. This is a periodic, like time series drought condition from way back or to a few days into the future. I think I'll move just to show you case few other land use and land cover things that we're able to do. We have the East Africa Forest Watch, which is already up for any person who is willing to or rather interested in this. We have fire monitoring within some of the protected areas. Yeah, so I think I'll just stop it at this point. Probably allow for anyone who has a question. But just to wind up, we have the carbon emission reporting tools that we are almost finalizing, but it's also already incorporated into the East Africa Forest Watch, where you're able to see areas that have been highly degraded in relation to carbon accounting. Back to you.
Yeah, thank you very much. This is really interesting talk, and then thanks very much for your on time. And also, I would like to remind that please mute your micros that we don't hear any echoes. So now I would like to open this the session for questions. 5 questions. I have seen some of the question in the chat. Let's go through that. I think now I can see that either drought in the Eastern Africa. We have, okay, this is the comment, I think, by this Laban. If you want to make more comment, then please tell us. Let me see if another question. Okay, that's it. Okay, you can chat. You can do it in the chat. But if somebody wants to ask question to David,
there is. Let me respond to Laban Maio. Yeah, I was just trying to allude that currently, yes, we're experiencing the long rains, El Nino. It's sort of above average rain within the region. But I just mentioned that it's already projected in the next maybe 2-3 years, we might be experiencing drought of similar magnitude as what we're experiencing now. Thank you.
Yeah, thank you, David. Any more questions to David? Please go ahead, because I don't see your if you are raising hands, but just, yeah, Maurice, Monica, please.
Yes, this is beautiful. This is beautiful. The presentation is beautiful, and I've loved the way you have displayed your data or your information on the various. My question was basically on the one that you have displayed in terms of points. There was a map where you're showing us data in terms of points, indicated the hotspots for. I don't know whether you're able to quickly go to that map. Okay. Anyway, my main contribution was just to appreciate the way you have displayed your data. And I think it is something that is easy to communicate, especially to the users who may be interested to just get overview or quick information about what you are presenting. Yeah, but my main question was on the one that you have presented using points to say.
But I think slides will be available, so you can also contact with this to David in my email. But
okay, all right, thank you.
Let's go to
Thank
Albano Santos.
Yes, good afternoon to all of you. Just a good presentation from David. And Albano de Santo, and I work for SASCAO. SASCAO is also an institution linked to the climate change and land management, land adaptation and management in Southern African area. And we also work, we are also collaborating with within GMS and Africa project. And I'm just looking maybe for an opportunity where we can also showcase in other sessions, or maybe next time with you for us to showcase our product and service, and maybe to exchange some of methodologies and see the best way where we can improve our products and services that we have.
Sure, that will be good. Albano, please write in the chat your contact addresses, so that maybe we could invite you for the webinar, also the next webinars, and also for the further collaboration.
So this is a presentation, an introduction to the Copernicus Atmosphere Monitoring Service. And my next presentation will be about the Copernicus Climate Change Service. So this presentation, I'm presenting actually on behalf of Laurence, who's the director of CAMS. So, so the Copernicus Atmosphere Monitoring Service, or CAMS for short, is one of the 6 Copernicus services. Copernicus is the European Union's operational Earth observation program, and it includes a fleet of satellite constellations to monitor the Earth's land, atmosphere, oceans, and also cross-cutting services, including climate, security, and emergency management. And ECMWF is entrusted with running 2 of these services, so the Atmosphere and the Climate Change Service. So in addition to the satellites, you have a service component, which are these 6 services, which involves taking the satellite data and also providing value-adding services. So what does CAMS provide? So CAMS provides free and open information products based on these satellite data. And that includes information about the past, current, and near future global atmospheric composition. So it provides forecasts, but also reanalysis data. It provides information about the ozone layer, so stratospheric ozone, the Antarctic ozone hole, but also, tropospheric ozone. European air quality, emissions and surface fluxes of key pollutants and greenhouse gases. Also solar radiation, so providing information to the energy sector, photovoltaic plants, also information about UV radiation, which is also linked to the ozone layer, and also climate radiative forcing. So CAMS provides information about all these different elements. And the way it works, so you have the Earth observation data from satellites, and you also have in situ measurements. And we then assimilate this data into our model, the CAMS main operational data simulation modeling systems. So ECMWF has its IFS, then we also have an atmospheric composition component. This data is assimilated into the model, and then we provide outputs in the form of forecasts. And here you can see some animations of total aerosol optical depth, and this is over South America and also over Europe and North Africa. But in particular, with the products that are produced by CAMS are used by many different users. So here you see a number of figures here. 33,500 users, but 3,200 really routine active users. But much more than that, CAMS exists in a certain place in the data value chain, and we provide products to downstream services who then support their own end users. So these include, businesses developing applications. Maybe they're taking our data and providing downscaling to provide high resolution data at local scale. Also news channels. So the multiplication factor is huge. It's many times more than, we reach many more users than the direct users of our data. So we really serve these downstream users, these downstream services who then serve a much greater pool of users. And yeah, in terms of the Earth observation data that we use, so, as I mentioned, the observations are then integrated with the model. So in the case of CAMS, the atmospheric composition data used for assimilation is actually only based on satellite data. But of course, the ECMWF integrated forecast system assimilates many more data streams. But for the atmospheric composition component, we're mainly assimilating satellite data. And you can see in this table a long list of different satellite instruments. And used to monitor many different species. So mainly CO2, ozone, NO2, SO2, CO, and these kind of aerosols. So for these kind of species. But in terms of the in situ data, so the in situ data is used for verification, and it's also used for the regional system. So in the global system, the atmospheric composition is only assimilating satellite data, but in the regional systems, we're assimilating also in situ data, and there are many different in situ networks. So from IMEP to Actris, also the aircraft IAGOS for aircraft data. The WMO Global Atmosphere Watch program also coordinates the collection of many different data from different sources. So we're using many networks of in situ data as well. And in terms of satellite data, so there's, in addition to the table I showed in the previous slide, there are also some new developments soon to come. So we have the Sentinel-4 and the Sentinel-5. So Sentinel-4 will be on a geostationary satellite platform, the Meteosat 3rd generation sounder. Sentinel-5 will be on the polar orbiting METOP system run by EUMETSAT. So in fact, these are both systems run by EUMETSAT, developed by ECEM, run by EUMETSAT. And also the CO2 monitoring mission, which is one of the next Sentinel missions. There'll be a constellation of 3 of them. And then there's also the global geostationary constellation. So that includes the GOES, but also some GEMS, which I think is a Korean geostationary satellite, and also Tempo, a North American one. So these data from all these satellites are used in CAMS products. And this slide just shows the impact of of adding new data streams. So this is a continuous effort in CAMS. This is just an example of simulation of tropomic carbon monoxide data. So from Sentinel-5P, which provides additional information, in particular in the lower troposphere, but also in other parts of in other layers of the atmosphere. And here you can see in these figures the relative carbon monoxide bias is reduced with the Sentinel-5P compared to what we had before. So we also have, we provide forecast data for the future, but also reanalysis data from the past. So basically, the reanalysis is like maps without gaps. We have we're using the observations with the latest model run to really fill in the gaps in space and time and provide a consistent data set going back into past decades, where you can really look at trends. So in this example here, this is the 2022 annual mean of PM 2.5. And you can really see where the, where the higher values are over the long-term average. So this data set is freely available through the CAMS data store. And in terms of what you can do with this data, so this is just an example of showing the PM 2.5 climatology. This is for 20. We now have data for 20 years now, so you can do a proper analysis of the climatology. So on the left-hand side, you see the climatology of PM 2.5 from 2003 to 2019, and then on the right-hand side, June 2003 to 2019. And then on the bottom, you see the anomaly with respect to this climatology. And you can see that where, there are certain fire hotspots, these are actually lower than the climatology. So it puts events into context. Whereas, for desert dust, you see this is actually slightly higher than average. So the reanalysis data is really good for understanding these kind of long-term trends and to put events into context. So this is an example of Saharan dust. So another component of the CAMS service is to provide analysis of various different events. So, these include dust events, wildfire emissions, volcanic eruptions, and we have a CAMS weather room where these events are analyzed, and then, information can then get sent to the press or shared in social media. So in this case, this is a dust event, and you can see in the figures on the left-hand side the comparison of the model with the ERONET observations, and in the middle you can see this animation here. So this is for a volcanic eruption. You can see the SO2, the sulfur dioxide plume, and this is the Cumbre Vieja volcano on La Palma. And there's a good analysis of this. You can see an animation of this event, and also a comparison again with the ERONET observations for a time series. And here we have another figure of wildfire emissions. So here, in addition to looking at a particular, month in 2023, so an animation over every day in January, you can also see that put into the context of the long-term history of wildfire activity. And all this information, you can get from the website. Also, if you look at the various different press releases, and of course the data you can get hold of for free. So this is all, this is all freely available. In terms of greenhouse gas information, so we have various different products. So we provide activity-based emissions for, I think, 6 different sectors, but also inventories, emission inventories, anthropogenic, but also natural emissions. So that's, from aviation, shipping, land, but also natural from vegetation, from ocean and soil. So this is all available on the Climate Data Store. And then, of course, we also provide forecasts. So the global forecasts are 5 days, up to 5 days ahead. Hourly intervals if you want the single level. If you want multiple levels, then it's 3 hourly. And then for the European forecast, it's up to 4 days ahead. So and also we have updated flux inversions. Hello, I think there's someone has unmuted themselves. So yeah, so we also have the annually updated flux inversions for CO2, methane, and N2O. So we also provide climate forcings. So this figure shows climate forcing for carbon dioxide, methane, ozone, and aerosols, and you can see that while methane and ozone are pretty much haven't changed significantly, the aerosols actually going down, but of course the main component here is the carbon dioxide, which is very much going up. So in the CAMS, in CAMS we provide analysis of this, and we're monitoring this, and this information you can get on the website. And this also provides input to various different reports, like for IPCC. In terms of emissions, there's also, let's say the new front line is the observation-based emissions. So here we're combining observations of atmospheric CO2 and methane combined with what we already know from emission inventories and statistics and data on human activity. This is integrated into models, and outputs are provided to different sectors, both at the local scale and then also the global scale, supporting the Paris Agreement. And then it goes to users, and it provides support to policy making and industry across different sectors. And in terms of the timeline, so it very much started with research activities. So there are a number of different research projects. So Horizon 2020, Horizon Europe, and then gradually going into operations. And the main point to get across here is that soon we'll have these satellite missions such as Sentinel-4, Sentinel-5, but also the CO2 monitoring mission, which will now be able to actually monitor. Instead of just using simulated data, we actually have the data, and this data can be used for operational monitoring of emissions. So again here, taking these observations, combining them with prior information, and then providing services to support decision making. So we're now at a critical phase where we're gradually going into operational monitoring of these emissions.
Chris, 2 minutes.
2 minutes, great. Okay, thanks. This slide just is just to illustrate that the data is freely available from a number of different sources. So we have the actual data on the Climate Data Store. but also we contribute to, the European Climate and Health Observatory, and the data is available through different from different sources. So this is the yes, okay. So we also have training as a core component of this operational service, because CAMS is an operational service, and in any operational service, user support and training is very important. So we have a training course on atmospheric composition coming up in September in Norway, and we do a lot of training also in collaboration with EUMETSAT and ESA. So this is, in order to get the data, you go to the catalog, you register, you only have to do that once, and then you can search the catalog for different data sets and different variables within that data set. Then you just have to, put in the various different parameters, which variables you're interested, which time period, which model in some cases, what level of the atmosphere. And then you can just download the data directly, or you can download it programmatically using an API. So if you want to iterate over a number of different time steps or variables, then you, instead of having to always go to the form and clicking in the web form, you can do that programmatically. And then, so just to mention that Wikio is, if you want a platform where you can use virtual machines to run various data processing, or if you want to also combine the data with other data from different Copernicus services or satellite data, then you can do that from within Wikio. So this is a kind of exploitation platform where you can access data from different sources, and you have also processing tools and Jupyter Notebook platform where you can actually run the processing. So this is a paper that was published in the American Meteorological Society. This provides a good overview of CAMS, so I recommend you to read this. And then just to conclude, so CAMS, it's an operational program, one of the Copernicus operational services, and it provides operational quality assured information about air quality worldwide. And this is all freely available. There are many ways to interact with the data, depending on whatever needs you have. Of course, validation and verification are very important components. There's never enough of it. And we're always trying to develop that further. And we do a lot of stuff we did a lot of work in collaboration with EUMETSAT and ESA, especially in training and user engagement. And yeah, and with that, I finished this presentation on CAMS.
Thank you very much, Chris. Before we move to your second presentation, let's have some questions that at least I have seen some of them in the chat first. So let's go through that. First question, what caused fire emission decline? There has been some in your slides, maybe some or declaration.
Yeah.
Do you have, yeah?
I don't know the reason for that. I think if you look at some of the press releases, maybe there'll be something about that. I'm not an expert on that myself, but if you're interested to know, I can find the answer for you, and I can or find whatever information that we have, and I can share that with you.
Although in Europe we have this more fires is coming up, but of course this is a maybe global fire emission. Maybe that's the kind of thing.
Well, I think in some places it's very much going up. Like in Canada,
yeah,
recent years have been just unbelievable, much greater than before. So I don't know. I think in this case it's just over Africa. There was it looked like they were going down. I don't know the reason. I don't know the reason for that, to be honest.
Which is the good news.
Yeah. At least some good news. Yeah, exactly.
Yeah. So the other question: what do you provide examples notebooks?
Yes, we do. So we have Jupyter notebooks that demonstrate how to process CAMS, how to access the data, how to visualize the data, and how to do certain processing steps. So these are on the CAMS website in the training section. If you just go to help and support, and then you'll find a section on training, and there you can access freely a number of different Jupyter notebooks that have processing workflows that you can use as a template for your own activities. You can take them, you can modify them, apply them as you wish. So yeah, we have them, and we're also developing. We'll develop more in the future as well.
Yeah, thank you. Is CCN data also available?
Sorry.
CCN data also available. I think, is it CCN data is I don't know what is this acronym, but in the chat it's is it like
CCN. Hang on, let me see if I can go
yeah,
to the chat so I can see
CCN.
what.
Or maybe Sophia will put the question if you want
Yeah,
to
Sophia
explain better.
Yarvinen, you can maybe ask
Ah.
directly.
Cloud condensation nuclei.
Okay. I don't know. We'll have to, if you go to the climate data store and you look at the various data sets, in the overview page of every data set, there's a list of all the different variables that are available in any particular data set. So I don't know if you're interested in forecast data or reanalysis data, but whichever one you're interested in, if you go to the climate data, the atmosphere data store, sorry, and you just, you look at the overview page and you'll see a long list of all the variables that are available.
Perfect. I think these are the chat because the ones answered by the Carolina already. So is there any online question you want to ask? We have still a few minutes to go, like 2 minutes. If somebody would like to ask, please raise their hand or just speak directly before we move again, Chris, second part of which is the climate change service. I don't see any raised hands. Okay, yeah, so maybe Chris, we can move.
Yep.
Second part of your presentation. Thank
Great.
you.